All right, today, everybody, what we're going to be discussing is we are going to be discussing the properties of a 45, 45, 90 triangle. And we're also going to be discussing the properties of a 30, 60, 90 degree triangle. In discussing these, you're like, I don't see any triangle. But I need you guys to understand where they came from. Okay? The 45, 45, 90 degree triangle came from when you took a square. Now, what are the properties of a square? All the sides are what? Equal, right? So all the sides are equal. So I'm going to write down double tick mark, double tick mark, double, double. So all the sides are equal. What are all the angles in a square? They're all 90 degrees. What I'd like you to do is I'd like you to take this square and I'd like you to cut it perfectly in half with it from diagonal to diagonal. And when you do that, what I'd like you to do is I'd like you to label this 45 degrees and like you to label this also 45 degrees. And if you have a color, great. If you don't, you can still shade it in with your pencil. What I'd like you to do is I'd like you to color that in. You should probably be able to do this a little bit easier than me, so be a little bit more precise than I am, but there we go. This right here, what I'm shading in, is considered to be a 45, 45 degree, 45, 45, 90 degree triangle. Now, something you should notice, if I take a square and I cut it in half, okay, with the diagonal, understand, what have I done to that 90 degree angle? I've cut that 90 degree angle perfectly in half. Why am I allowed to do that? Because a square is a rhombus. And in a rhombus, the diagonals always bisect that corner angle in a rhombus. Okay? So what we're going to do right now is we are going to just make just a 45, 45, 90 right underneath it. Okay? So if you would, please, right underneath this, I want you to make, you don't have to shade anything in. Just put 45, 45, and make a 90 degree angle right there. Now we're going to do a little bit of extra work here to show you a cool pattern where you don't have to do extra work. Now, what topic did we just cover when we were trying to find the hypotenuse of right triangles? Pythagorean theorem. Now, what we're going to do right now is we're going to do the Pythagorean theorem just for practice. Okay? So, what does the Pythagorean theorem state? It says a squared plus b squared equals what? C squared. So what is our a value? It's a 4, right? A and b are interchangeable. What's the other leg? It's also a 4. So 4 squared plus 4 squared equals c squared. Now 4 times 4 gives us a 16. And 4 times 4 also gets us a 16. You add those together, you get 32. Supposed to be a c. Alright? And then what do we have to do to both sides?
Square root.
Take the square root. Now listen, I don't want the approximate value for this. I want the exact value. Now what would you have to do to break down that 32? What could I break it into? Well, I'm going to break it into a 16 times a 2. I'm going to break that into a 4 times a 4. Look what I have. 4 miracles. So what is my c value? It's 4 radical 2. So what I'd like you to do right here, put equals 4 radical 2. Now we did a whole bunch of work right here using the Pythagorean theorem, but I did all of this work to tell you that you don't have to do all this work if you know the properties of a 45, 45, 90. So here are the properties, everybody, that you're going to make a little chart. Put 45 degrees. Put 45 degrees. Put 90 degrees. We're going to make a little chart right now. In your journal, you're going to put x, x, x radical 2. You're like, what the heck is x? X is always your shortest side. I'm going to put short side. Okay? So what did we have? What was our shortest side? A 4. A 4. And what was our hypotenuse? 4 radical 2. So I'm going to continue this pattern and show you how easy it is. What if I said my triangle, my shortest side was a 10? What's my other leg going to be? 10. What's my hypotenuse going to be? 10 radical 2. What if I throw another number? What if I put a 7? 7. 7 radical 2. What if I said my length was a happy face? What's the other side? And what's the hypotenuse?
Radical 2.
There we go. Happy face, radical 2. That's your pattern. That's your shortcut. Why did I do all this work? Because I wanted you to show that even though I had a 4 and a 4, and I did the Pythagorean theorem, what did I eventually get to? A 4 radical 2. So it's a shortcut to get you to your hypotenuse. So I'm just going to do a quick example before we do the 30, 60, 90s. Here we go. Just going to make a quick little example, see if you guys can follow along. So here we go. You got a 45, 45, 90. How do you know? If I put a 45 degrees right here, and I put a 90 degrees right here, that also has to be 45. What if I call this side x? What's this going to be? X. What's this side going to be?
X.
There is your pattern. So could you guys please put this pattern in your journal so that you have it? And what is x always equal? X always equals your shortest leg. In this particular case, the shortest legs are exactly the what? They're exactly the same. So write that down. And then we're going to go back and talk about the 30, 60, 90. All right, I'm going to go back to this page right here. So what you should have in your journal, you should have this chart right here as a guide, okay? And you should have what picture? Oh, not that one. This picture right here, okay? All right, so right now, I'm switching colors. We're dealing with an equilateral triangle. Does everybody realize that this right here, I attempted to the best of my ability to draw an equilateral triangle. What do we know about all equilateral triangles? All the sides are equal. So put a double tick mark, and I'm doing a double tick. So we got a 4, and a 4, and a 4. I don't know, but we have 4, 4, and 4. Now, this is what I want you to do now. Check this out. I want you guys to take that equilateral triangle, and I want you to split it perfectly in two. And what I'd like you to do is shade in right here. Just shade this one of the triangles in. Now, I don't know if you guys can see this, but hopefully you realize that this is a 90-degree angle. Now, what are the corners of all equilateral triangles always equal? 60. So we have a 60, 60, 60. So I'm going to put 60 right here. I'm going to put 60 right here, but all the way across is a 60. So what has to go in that little tiny corner? So that right there. That's why I'm putting a little arrow. That's 30 degrees because I couldn't quite fit the 30 degrees in. Okay? So what happens when you take an equilateral triangle and you cut it down the middle? It becomes a 60, 30, 90, also known as a 30, 60, 90. So right now, what I'd like you to do, right here, from right here, go up about 3.5, go over 2, and go down just like that. And then I want you to label, this is your 30 degrees, this is your 60 degrees, this is your 90 degrees. Now everybody, this side right here is a 4. I know it's a 4. What is this side right here? 2. Uh-oh. What if I said, I want to know what B is equal to? This time we're not going to use the Pythagorean theorem and find our hypotenuse. What are we going to find? We're going to find our legs. What I'd like you to do is write this formula. Put B squared equals C squared minus A squared. All right, so what we're going to do right now is we're going to find this side. Okay, we're not finding the hypotenuse, we're finding the side. So right now, put B squared equals 4 squared minus 2 squared. All right. So we have our hypotenuse squared, which is 16. We have our other leg squared, which is 2 times 2, which is a 4. So what is our b squared equal to? 12. So what do I have to do to both sides? I have to take the square root of both sides. Uh-oh, can I break down the 12 to a 4 and a 3? That breaks down to a 2 and a 2. And by the way, at the very beginning of class, Linux, what did I say I wanted you to tell me the approximate value of? No, I told you, hey, could you type in the calculator find the approximate value of 2 radical 3?
Yeah, I thought I was thinking about when you said if you wanted the exact amount of approximate.
So right here. So what is, by the way, what is 2 radical 3 approximately equal to? It's equal to what? A 3.46, which is really close to a what? 3 and a half. That's why I drew up 1, 2, 3 and a half for this leg. Okay? Now, what is the exact answer? It's what? 2 radical 3. Now, right now, you're probably still wondering what, I don't see the pattern yet. So we're going to build the pattern. We're going to build it right here. So here we go. Right, 30, 60, 90. I want you to put x. I want you to put x radical 3. And then I want you to write a 2x. Now, what, by the way, x still represents, everybody, x still represents your short side or your shortest side. What was our shortest side in this 30, 60, 90? A what? A 2. What was our 60-degree side? What is the side that's opposite the 60-degree angle right here? 2 radical 3. And this is 2x. What does 2x mean? It means 2 times x. What is 2 times 2? That's why I got a 4. Now, what we're going to do is we're going to give you some more examples. So right now, let's just say I made up an example and said, ooh, what if your shortest side was a 7? What's your middle side going to be? 7 radical 3. What's your hypotenuse going to be?
14.
14. One more. Here we go. What if I said, since I'm running out of room, what if I said your length was a whoa, that's a weird face. Happy face. What's this side going to be? That's right. Not unibrow, radical 3. Sorry. Happy face, radical 3. And what's this going to be?
Happy face x.
Happy face squared. 2 happy faces.
There we go. 2
2 times happy face.
2 times happy face. All right, 2 times happy face. Now listen up. We're going to go over here. This is what I want you to draw right now. Everybody, the last thing I want you to draw in your journal is this right here. I want you to pretend that this is a 30-degree angle. I want you to pretend that this is a 60-degree angle, and I want you to pretend that that's a 90-degree angle. And what I'd like you to do is label this x. Label this x radical 3, and label that 2x. So in your journal, what you should have for your 30-degree, 60-degree, 90-degree triangle, you should have x radical 3, and a what? 2x. And what was our example? Our example was a 2 radical 3, and a 4. Over here, for the 45, 45, 90, you should have this in your journal. 45, 45, 90, x radical 2. And what was our example for that? A 4, and a 4, and a 4, radical 2. Those were your examples.